Okay, so the last section is how it relates to houses. How does thermodynamics relate to houses? So it relates to houses in terms of heating and cooling. So we design houses in particular ways. We can make the most of the heating and cooling, natural heating and cooling effects, rather than having to run heaters and air conditioners and the like. All right, and so this is called sometimes passive solar. And so key idea, of course, is heat energy goes from hotter to cooler. All right, so heat energy transfer. So what can we do to help? So for example, is if we want to keep heat in, all right, so in our house, say in winter, for example, we want to keep heat in, what do we need to do? Well, air movement, right, because convection, if we let air move out of the house, it'll take heat with it. All right. So the other thing what we can do is increase thermal mass. What does that mean? Well, what that means is construction materials that retain heat. All right, so we can put materials in our walls and ceilings that will keep the heat in, and we call that insulation. But concrete and bricks and tiles also work in that way. All right, so that's one thing: insulation and thermal mass. Okay, what else can we do? Well, other things we can do is like this diagram kind of indicates. So we can orient our house in a particular way. So here it's north up here, if we're in the southern hemisphere. And so in the winter, when the sun's low, we could have the sun shining into our living room. And so that helps heat up, and as it says, thermal mass flooring. So, concrete slab or the like. And so we get sun in the winter time. Now in the summertime, we don't want the sun in, so the sun's up high in the summertime. So what can we do there? Well, we can put things like these little pergola things that shield our windows. Take those out, otherwise a bit of a mess. And so the heat doesn't get in as much. Also, what else can we do? Well, we can put louvers and vents and things. So here's some louvers and vents. And so we get some ventilation. Now in the summer we can open them up and get the cross flows that diagram nicely shows. And then in the winter we can close those up. All right, so in your notes there's a whole bunch of different 3 dot points there in the first part above this. So positioning windows on the north side of the house, wide eaves, as I mentioned with these in the summer, small windows on the south side, reducing the heat loss in the winter, but allow ventilation in the summer, and allow living areas on there and the work area there, the study on the other area where it's a bit cooler. All right, so that's one part of house design. Another thing we can use in the house design that's being used more and more these days is double glazing. And yes, it's more expensive to do it, but in the long run, if you're building a new house, in the long run, if you're going to be in there for 20 or so years, it helps you. So what is a double glazed window? Well, here's a diagram. So we've got double glazing, because we've got two bits of glass there. So that's the double glazing. We have an airspace or some other gas in between. We have a spacer that keeps them apart. We have a desiccant. So what is a desiccant? So that absorbs water. So we don't, have it all fogging up in between. And then we've got a seal to keep it so that water and stuff can't actually get in. So what's so good about double glazing? Well, glass actually lets radiation through. So because glass lets radiation through, you get, in the winter time, you heat inside, you get a lot of radiant heat going out. But by putting double glazing in there, that actually keeps that radiant heat in. It's more difficult for that radiant heat to get through two lots of glass than it is one, quite significantly more difficult. So in the winter time, it keeps it in, and then in the summertime, keeps that lot of that radiant heat out. However, what it doesn't change is the visible light that can get in. So we still allow visible light to get in. So in your notes there, so double glazing reduces heat loss, and quite significant. All right. So in the notes, it's a bit. That doesn't make sense there. In the summer, a window can allow up to 100 times the heat transfer. It should say an equal size wall there, not. It should say 100 times the heat transfer of an equal size wall. So compared to these walls here, the heat transfer of a window. All right, so it says there, so double glazing can cut that in half. So instead of having 100 times the amount of heat transfer in the summer coming in here in the summer, it cuts that in half, which will help keep your house significantly cooler. All right, so that's the last bit, and so we've got problem set 9. Which is in your book.